Good day class, welcome to his physics tutorial. Today we're talking on confidence interval. Confidence interval is simply the estimate of a range where the two population likely falls. Let me explain this with a normal distribution curve. So this is a normal distribution curve. We have the curve. Here is called the population mean. This place is called the confidence interval. Why here are called the tails. Here is called the confidence interval. This place are called the tails. So if the question says you have 95% confidence interval, meaning all here is 95%. After 95%, many 5% will make it 100. So you share the many percentage with the tails. So here will be 2.5% and here will be 2.5%. So this place now is the estimate of the range where the two population likely falls. So that's what confidence interval is likely about. So we have three methods, or otherwise three cases of solving confidence interval. We have case 1, case 2, and case 3. For case 1 is when your variance is known. Let's call V variance. So variance is known and your sample size N is greater than or equals to 30. This is for case 1. Case 1 is when your variance is known and your sample size N is greater than or equals to 30. For case 2, your variance is unknown and your sample size is also greater than or equals to 30. This for case 2. Your variance is unknown and your sample size is greater than or equals to 30. And finally, for case 3, your variance is also unknown, but your sample size now is less than 30. So these are the three cases for solving confidence interval. Now let me give you these three cases now have in their individual formulas. Case 1 has its own formula, case 2 has its own formula, and case 3 has its own formula. So let me show you the formula for case 1, case 2, and case 3. Okay. So now these are the formula for the cases. So we have formula for the cases of confidence interval. So now for case 1, the formula is mu equals to x bar plus z square brackets standard deviation over square root of n. No worry, I will explain the parameters when I'm done with the formula. For case 2, we have this. And for case 3, we have this. So now, these are the formulas for the three cases. Case 1, which is when the variance is known and the sample size is greater than or equals to 30. Case 2, for when the variance is unknown, sample size is also greater than or equals to 30. And for case 3, when the sample size is unknown and when the variance is unknown and the sample size is greater than 30. So now, for this formula, let me define the parameters. Where U equals to population mean, U is the population mean. X bar is what sample mean. This stands for Z sub. This is what your standard deviation. This is your standard deviation SD when variance is known. When variance is known. What is next? N is your sample size. What is next? And S is your standard deviation when variance is unknown. So these are your parameters. This is the formula for case 1, formula for case 2, and formula for case 3. And these are the parameters. U, population mean, X bar, circle mean. This is this called, this is the standard deviation when variance is known. So if you watch, it's only case 1 that the standard deviation is written like this. Because it's only case 1 that the variance is known. For case 2 and case 3, the variance are both unknown. That is why standard deviation is written as S and S. This is the sample size. This is the standard deviation when variance is unknown. So now let's try solving problems with these 3 cases. Okay, so we have a question here. The question says, a random sample size of 30 students selected from a class yielded an average weight of 260 kg with a variance of 4,900. Determine the 5% confidence interval, CI 5% confidence interval, for estimating the average weight of 30 students in future. Now, solution. First step, identify which case. Is it case 1, case 2, or case 3? So from this question, it said with a variance of 4,900, meaning variance is given. So it's what? Case 1. Case 1 says what? Variance is known, n greater than or equals to 30. Case 2, variance is unknown, n is less than or equals to 30. And case 3, variance is unknown, n is less than 30. So from this question now, variance is known, so b equals to 4,900. And n is greater than or equals to 30. N here is 30. So 30 is under greater than or equals to 30. So this is case 1 problem. Let's write it case 1. This is a case 1 problem. So now we have when our parameters given. V is this, N is this. The average weight, what does that mean? The X bar equals to 260 kg. Because from the video on hypothesis test, I said average stands for what? Mean. So now I said average weight is 260 kg, meaning the sample mean X bar is 260 kg. With a variance of this, determine the 5% confidence interval. So CI equals to 95% for estimating the average weight of the student, meaning the population mean. Average weight of the student is what? Population mean. So our mean equals to unknown. So from case 1, U equals to what? X bar plus Z log brackets standard deviation all over square root of n. This is formula to find our population mean for case 1. Because this is a case 1 problem. Do you have our X bar? Yes, we have our X bar. We have our standard deviation. Sorry. We have our variance. We have standard deviation. We can find it easily using the square root of variance. Square root of variance is standard deviation. So we can find it easily. Do you have our N? We have our N, but we don't have our Z score. But first, let's find our standard deviation first. So standard deviation equals to what? Square root of variance. So standard deviation is square root of variance. So we can say square root of what our variance? 4,900, which is what? 70. So our standard deviation is 70. That's gotten our standard deviation. What is next? Find our Z score. To find our Z score, we use our Z score table. But before that, remember, the standard confidence interval is what? 100 bracket 1 minus alpha percent. This is standard confidence interval. It's inherent total. Standard confidence interval is what? 100 bracket 1 minus alpha percent. This is the standard confidence interval. It's constant. But this question, see that confidence interval is what? 95%. So meaning we can say 100 bracket 1 minus alpha percent equals to the one we gave in our question, 95%. Let's find our alpha. So let's buy both sides at 100 to do this percentage. So you can say over 100 over 100. So meaning this will cancel this. So 1 minus alpha equals to 0.95. Alpha equals to 1 minus 0.95, which is equal to 0.05. This is our alpha. Because now alpha, you're going slowly. But now, we said this score is what? Alpha over 2. Alpha over 2. So meaning to get our z score, we need to divide this alpha by 2. So we can say divided to get our alpha over 2 is what? 0.05 over 2, which is 0.025. This is our alpha over 2. We're looking for our z score. To get the z score inside our z score table, we need to find the cumulative distribution. And cumulative distribution is 1 minus whatever value you get after getting alpha over 2. That's how you get to cumulative distribution. 1 minus whatever value you get after you get to alpha over 2. So cumulative distribution CD equals to 1 minus this guy. This is our alpha over 2, 0.025, which is 1 minus 0.025, 0.975 is our cumulative distribution. So now you go to your z-score table. Don't forget, so what's our cumulative distribution? This is what you use in your z-score table. So you go to your z-score table, you look for 0.975. So from here, 0.975. 0.975 is under 1.9 and 0.06. 0.975 is under 1.9 in the vertical and 0.06 in the horizontal. So meaning finally our z-score value now equals to the value we get in the horizontal, which is what? 1.9. Because if you trace 0.975 going to the left is 1.9 and up is 0.06. So it's 1.9 the one here plus trace it up is what? 0.06. 0.06. So if you sum this together, we have 1.96. So this is our z-score value. Now let's put it in our formula and get our population mean. So now finally, our population mean now mean equals to x bar is what? 260 plus z-score is what? 1.96. 1.96 brackets. This is what? 70. All of our square root of our n is what? 30. The square root of 30. So therefore our population mean now is our mean is, sorry, this is plus or minus. Sorry, I omitted that. In that formulas, both of them have plus or minus. Sorry, I omitted that. So we can say sharing this out, I can say 260 plus 1.96 bracket 70 over 0. Over 30 or 260 minus 1.96 bracket 70 all over 30. Don't forget the formulas for both case 1, case 2 and case 3 has plus or minus. I omitted it the first time, please, when solving add it. So now meaning for me, I can say our mean now is all this one first. We get 285.05 comma 0.7. You get 234.95. This is the population mean. Meaning the population mean ranges between 285.05 to, oh sorry, small to big. Ranges between 234.95 to 285.05. This is the population mean, and this is the final answer. So let's solve another problem with another case. So we have another question here, working example 2. Question says the average lifespan of 5 light bulbs measured in hours produced by companies given as follows: 35, 80, 70, 40, and 48. Determine the 95% confidence interval limits for assessing the average lifespan of light bulbs produced by the company in the future. So we have a solution. What do we have? We have that the average lifespan is what? N. So N equals to 5. The number of light bulbs, 5. Is given our measure by company as follows. The confidence interval is what? 95%. Essentially, calculate the average lifespan of the light bulb produced by the company in the future, meaning our population mean equals to unknown. So now what's the first step in solving confidence interval problem? Identify the case. So for this problem now, what case is this? Your n is less than 30 and your variance is unknown. That is what? Case 3. This is the case 3 problem. N is less than 30 and your variance is unknown. So what is the one case 3? From mu equals to x bar plus t score brackets standard deviation over square root of n plus or minus. Stick my mind in plus or minus. So what do we have? We're looking for this guy, right? Do you have me? Do we have our sample no? Do we have our t score no? Do we have standard deviation no? We have n, yes, Jesus. What a question. Only n we have. So we have to find x bar, t score, and standard deviation. Let's solve it together. So now, what do we say? We say that the standard confidence interval is what? 100 bracket 1 minus alpha percent. This is your standard confidence interval. So we can say, equating to the confidence interval given in the question, we can say the standard confidence, we can say 100 bracket 1 minus alpha percent equals to 95%. Now, divide both sides by 100 to give it the percentage. You can say over 100 over 100. So 1 minus alpha equals to 0.95. So alpha equals to 1 minus 0.95, which is equals to 0.05. So alpha over 2 equals to 0.025 because divide this by 2. Okay, so we are gotten our alpha. Now let's find our t-score. Remember, for z-score, we said to get your cumulative distribution is 1 minus your alpha over 2. While for t-score, to get your for t-score, work with degree of freedom, not cumulative distributions. Z-score is cumulative distribution, while t-score is degree of freedom. So we can say to get our degree of freedom now equals to degree of freedom is what? N minus 1, which is equal to, our n is what? 5 minus 1, which is what? 4. Our degree of freedom is 4. And now let's go to our t-score table. So in our t-score table now, if you check your t-score table, you see a column that shows degree of freedom. So you go there to 4. So right there, degree of freedom is 4. If you watch, but first, you identify what type of t-score table it is. Well, this is a two-tailed t-score table. When using a two-tailed t-score table, you work with alpha. I repeat, when using a two-tailed t-score table, you work with alpha. And when using a one-tailed t-score table, you work with alpha over 2. Let me jot this down. So, using a two-tailed t-score table, you work with alpha. And using a one-tailed t-score table, you work with alpha over 2. From the table we have here, this is a two-tailed t-score table, so I'm working with alpha. I'm working with this value, 0.05. So what are we working with? I'm working with 4, and log 0.05. Find our t-score. Now, go to your t-score table, go to the degree of freedom to be 4, then you trace for your 0.05. Degree of freedom for 0.05 is, the value is what? 2.776. You check 0.05 is something as 0.05. So 4 go to 0.05, 2.776. So our t-score finally is what? 2.776. This is our t-score. We have found our t-score. Now, what is left? To find our standard deviation and our mean. So now, let's find our x bar. We have found t-score. What is left? X bar and standard deviation. We really have n as 5. Let's find our x bar now. X bar now. Come up for x bar for a table without frequency is what? Summation of x all over n. Meaning, you sum this value and divide it by the total number of value, which is 35 plus 80 plus 70 plus 40 plus 48 all over 5, which is equal to which is 273 over 5 equal to 54.6. So we have gotten our mean. Now, let's find our standard deviation. Also, standard deviation for the table without frequencies was summation of x minus x bar all over n minus 1. Summation of what? X minus x bar all over n minus 1. So we can make a table. Let's make the table first. Make it easier for us to solve. This table we have what? We have x. We have x minus x bar. So x is what? The data 35, 80, 70, 40, and 48. So it's square. So we have here x minus x bar squared. So x minus x bar now, 35 minus 4.6. We have what? Minus 19.6. 80 minus 4.6. 25.4. 70. 15.4. 40. Minus 14.6. And finally 48. Minus 6.6. So this is the x minus x bar, which is your beta minus what? Your mean, which is 4.6. Now, x minus x bar squared. Square of 19.6. This is 384.16. Square of 25.4. That's squaring these values. You sum this value, but instead the formula is the solution of x minus x bar squared. So you sum the column last x minus x bar squared. If you sum it, you get 1,523.2. So now, finally, our standard deviation is what? Summation of this, square root of summation of this, which is what? 1,523.2 all over n minus 1. 5, n is what? 5. The number of data minus 1, which is 4. So quantum this finally we have 19.51. So these are our standard deviation. So now finally our population mean now is what? X bar, which is what? Let our x bar 54.6 plus or minus t score is what? 2.776 brackets, standard deviation is what? 19.51 all over square root of n is what? 5. So mu now, you add them and you minus, separate it. Minus first, because smaller value comes before the bigger value. So our final answer is 30.38 and 78.82. Don't forget, you subtract it first before you add it. Meaning the population will range from 30.38 to 78.82. This is our final answer. So we have an assignment now. The assignment. So we have the assignment. The assignment says a random sample of 30 players. So they have to right? Of 30 players selected from a multi with an average weight of 100 kg with a variance of 4,000. Determine the 90% confidence interval for estimating the average rate of players in the future. So identify the case, solve these assignments, and drop your answer in the comment section. Like, subscribe, and follow